Hello everyone, if you are interested in making a 3D web maps, so this lecture is going to be of your interest. As you are seeing, this is a Vienna city, and you see that they have created this 3D web map. And if you are interested, the following lecture on 3D city modeling will enlighten your further thoughts on 3D. I'm thankful Dr. Hugo Ludoix for this lecture. Thank you.
Hello everyone, my name is Hugo Ludoix and I work at the Delft University of Technology, and today I'd like to speak about the data sets that we as a community produce, or data sets that we as a community help produce. And in particular, I'd like to speak about this slide. So this is a slide that you've probably seen before. I've been using it for 10 or more years. My colleagues use it, and other people also have been using this slide in one form or another. This slide basically says that if we have access to semantical 3D city models, then we can do advanced spatial analysis and simulations. And the analysis and simulation that we can do wouldn't be possible if we didn't have semantic 3D city models. So if we only had 2D geoinformation, or if we had purely geometrical geoinformation. So this slide, I think, summarizes well the goal of the series of 3D geoinformation conferences. And that is for me to push further the 3D data modeling so that the data sets that we're producing are usable, can be exchanged and converted. And at the hub of this, which is central to all this work for the last 15 years, this community, we've been using the semantic city model, semantic data model, which is CityGML. So when I started using that slide 15 years ago, I thought once we have access to all the data sets, then everything will be possible. So I was super happy to see in the last few years, and I'm sure I wasn't the only one, that several cities around the world release as open their data sets. So New York and LOD, we have the whole of Switzerland, which is openly available in 3D. We have some data sets, for example, in Helsinki, where we also have the texture. Recently, this year, in 2020, 56 cities in Japan were released in CityGML, among others. There's also other format, but more and more cities are releasing everything. So as I said, I was super happy to see that, because I said, finally, this is something we've achieved it. And it's not only these cities, by the way, we also have more cities. So my research group, which I forgot to mention, the 3D geoinformation group at TU Delft, we maintain a list of all the openly available 3D city model, and we have now 41 cities or countries. But each of these data sets might contain more than 10 million buildings. So we said if we have data, then it's the key to unlocking advanced applications. So we should all be super happy, right? Mission accomplished, we've done it. That was my reaction at first, but I also noticed in the last few years that, there's a but, sorry to be for the but, that's what I want to reflect on. I'm not so sure if we are that successful. So I've noticed in the last few years a lot of anecdotes where the data that we were producing are actually maybe not used as much as we would like to. The first example is here in the Netherlands. So my research group, we help the government develop software, so that the software 3Difier, so that we can reconstruct in 3D an area. And the government used it to generate the whole country. So all the 10 million buildings, all the terrain, the road, the forest, the waterways were generated in 3D and put online on a server where the data are openly available. And we thought that it would be the start of people using our data set, but unfortunately, since then, I don't think I got a single email of someone asking me, hey, I've got a problem with your data set, could you do that? It's basically been put on this data set, and then I didn't hear anything about it. Doesn't mean that the data set has not been used, but I have a feeling that it's not been used that much. It's kind of ironic, because this project was hailed, and it's still hailed as a success, because from a data modeling point of view, that was really successful. So the government created an ADE, of CityGML, so the whole country is modeled as a extension of CityGML, and we released the whole country. So it was two positive things, but I think these two positive things together still didn't yield much in terms of usage of the data. I'll get back later on the ADE, but this was the first thing that I thought, oh, okay, maybe people are not that interested in our data sets. The second part is that we always say that CityGML is an international standard. It's there so that people can easily exchange data. But actually, if you look at the amount of software that have a file open CityGML, which would be required, right, if you want other people to use your format. So if you look at the list of formats supported by a lot of the 3D software, so these are software that I have on my computer. They go from MeshLab to Rhino to QGIS to Blender. I think these four. None of them have a file open CityGML. It's possible to open CityGML in some software, for example in QGIS, but it's usually really complex. So for example here, it's a blog post that my colleague Stelios Vitalis wrote a few years ago. Also how to be able to convert or to be able to open your CityGML in QGIS. And basically if you follow that, you're gonna succeed, but you need to be pretty much a developer. So again, file open is just not existing yet. This is a slide that was presented 2 weeks ago at a workshop I was attending by Raphaël Beauvier from Swiss Topo. And this is a slide that made me really think, and this is a slide that made me decide to make the presentation I'm making today. And this shows the percentage of download of different formats a few months ago for the Swiss Topo website. And basically, the main thing you should notice is that CityGML in green is only 3.5% of the download. And the bulk of the download, 79%, is actually a format which is not even a geo format, technically, DXF. It's a format that's used mostly by architects, I believe. I'm not really a big user, but when I saw that slide, I thought, oh, okay, 3.5% versus 79%, and also versus OBJ, which is a very simple format in computer graphic, which outperforms CityGML. So if you see this, you think, well, are we doing good? Yeah, I don't know. Raphael also told me to say that these do not concern the data right now as open. He didn't even have statistics now. This concerns the data before they were open. So this is when the portal people needed to pay. But anyway, so when people needed to pay, what they wanted to download clearly was DXF. And the last thing I've noticed in the last few years is that our community is not really having much impact on other communities, I think, or actually other scientists in other communities are not really involved in what we do. So if you look at R Spatial with the sample feature package, that's a package that's really maintained by a lot of people, mostly by Edzer Pebesma. And there they really have a community of people that are contributing to this package. And what is really nice is that the contributor to this package are not necessarily working with people working in geo, but they're soil scientists, people working on glaciers, people working in geology. So all these people, because they need to have access to their geometries, their geo polygons, they are actually working and helping maintain this package, so there's 84 contributors, and this is something I'm actually really jealous of, and this is something that I wish our community was able to create, kind of a momentum for other people to contribute to or to contribute to what we're doing, so that what we're producing is useful for them. These communities could be the CFD community, simulation communities, computer graphics. All these people could have an interest in using semantic 3D city models, but unfortunately for us, maybe fortunately for them, they're still using very simple format, OBJ and STL, and they're not really involved in what we do. So now today I would like to reflect on why is that? Why did we reach that point where we create data, but these data are not really used by anyone else than us, I think, or by very few use cases. I'm not saying that they're not used at all. I'm just saying that in other communities, data sets are used by a lot of different people, practitioners, in GIS, but also by people outside the field, and especially by scientists working in other disciplines. They are using the data because they use them. So why are the data sets not used? I'm going to make a list of a few things that I've seen that doesn't go as good as it should, in my opinion, just so that we can reflect and maybe correct them. The first one is that UML shouldn't be the main goal of our papers. If you notice in the last few years, if you look at all the papers published at this conference, a lot of papers have as the end goal UML. And I think that by doing that, we stay at the theoretical level, and then we basically ignore the users, or the users are not central to our exercise. And when we model with UML, our aim is usually to model the full reality. And it's very easy to add more complexity because it just means adding more classes, boxes, linking them. And then you say, yeah, that's pretty good. But in practice, you don't really look at the influence of what you're doing on the data set that you're producing. And it's not only the community. I think the community is linked to a lot of the standards, the OGC standards, and I think also the aim of many of the OGC standards. It's changing, but in the last few years was really the UML as the end model, and I think this is not really helping us having data sets that are usable. And if I speak of standard, there's something in the Netherlands, many municipalities and governmental agencies must use standards because the idea is that if they use standards, then they're not locked in by vendors. And usually we think that standards are really useful. But if you just look at the past, shapefile has never been a standard. And it was used for years by everyone. If you have a download portal, there's very complex format, GML and so on. But usually shapefile is what people click on. Until a few years ago, actually, I still click on shapefile because shapefile just work basically. And you should all follow, I think, shapefile on Twitter. This is pretty funny. Basically, it says I'll be there forever. So it's a bit of a joke account that says people are still using shapefile and I will be there forever. I'm not the only one finding it funny, so we're almost 4,000 people that follow this. So if I just made a quiz, let's say you're a soil scientist, you work with some polygon data and you want to store them. And then you have someone tells you, well, you could use GML or GeoJSON, and then you just Google and you check GML. If you check the specs, you want to know how can I store my polygons. You download the specs. The document is 427 pages. I just checked. And it's filled with data modeling parts that are not really interesting for you. So you just want to store your data. You want to know how does the snippet of data look like. It's really difficult to have access to it. You have all the definitions, and then you have snippets of schemas, snippets of XSD, which are not really useful for you because the only thing you want to do is have access to a snippet. Oh, that's how I'm going to use it. And then if you look at GeoJSON, then this one, the standard is very short, 28 pages, and there's no data models, there's no UML, there's no XSD, there's only snippets of example of all a point, a line, a multi-line, a polygon. You can just copy paste and you're done. So if you look at the amount of tools that we have for these two formats, then GeoJSON is really exploding. It's implemented in every software that I know of. There's a lot of websites supporting it and so on. So I think you cannot really compare these two things. One is successful and the other one is, in my opinion, way less successful. Another problem I think that we see is that we developed a lot of ADEs, and I'm also guilty of that myself. I've developed a lot of ADEs. I now regret it partly because I think that this is something that I shouldn't have spent my time on. But 5-10 years ago, the idea that you develop an extension to the 3D city model of CityGML was very attractive. So you developed an extension, you document it so that everyone can understand your data when you exchange them. But that was mostly theory, because I think in practice ADEs are, so there's a lot of ADEs, but if you look at the use of data sets that have ADEs, it's actually very, very low. And even worse, a lot of the papers that we produce as a community speak about ADEs, but there was a survey made by some people 3 years ago, and there was only 18 out of the 44 ADEs they could find that provided the schema, the XSD files. All the other ones basically had no codes. They only had UML, and some of them didn't even have UML. So if I say that we stay at the conceptual level, this is one example. Just developing the UML of ADEs is not really helping anyone, because the aim of an ADE is that you document it so that when you release your file, other people are supposed to be able to understand these files and maybe write the parser automatically. And this is the part that I regret this is why I regret developing ADE, is that when you develop an ADE, you basically take a very complex file and then you add more complexity to it. And the idea some years ago is that we could automatically generate code to parse ADEs based on the XSD, but it's not really a reality. And I know that some of you might say, well, I've succeeded for some cases. I know, but in general, if you put all your data into an ADE, then it's very difficult to expect software and practitioners in other fields to read that file, because it's basically, they will need to write even more custom code than they need to have to simply parse a CTGML file. So putting all your efforts into making ADEs is something that I think has not been very productive for the community. Since we focus a lot on the data model, the problem is that we have little focus on usable data set, I think. So one problem I see is that we develop the UML and then we assume that the encoding, often in GML, can be automatically derived from the schemas, which is true. There's several software to take UML, XSD, and to derive automatically the encoding. But the problem is that the data sets that you're generating are often hierarchical and they have a lot of annoying quirks. At the top here, you see two of them. These are small examples, but for developers, they can be very annoying. And this is only two examples. There's many more. If I scroll down a file, I could tell you many. And they're not only annoying, they're also error prone. So it's easy for a developer to make errors. And it's also, since they're annoying, then developers will be less tempted to develop for that data format, because they will think, oh gosh, again, I need to fix this and that. There's so many cases. So two examples. Here, if you want to store the appearance in CTGML, then there's the app::appearance with a small a, and then the child of that is app::appearance with a capital A. Why is there two? I don't know. One is capital, the other one is not. And it's very important. You cannot invert them. You need to do that. Again, not super important, but there should only be one of these two, in my opinion. Or they should be called something else. But these come from the fact that from the UML, the automatic code to generate these datasets generated that. There's many other examples. If you want, I can give you some at the end. Another part of assuming that we develop in theory the UML and then we automatically generate the dataset is that often, as I said, we use GML, but GML comes with a lot of history and everything needs to be backward compatible, and that comes with a price. And I think that the best example of that is my favorite blog post that was written 6 years ago, and it's called GML Badness. And basically the author lists how many ways he could find to store a unit square. So if you have a 2D square in the plane and you want to store it, how many ways do you think you have in GML? So you could say, oh, I hope that there's not more than 3 or 4, then it becomes complex. Actually, you wish that there was only one, but in practice, there's 25 ways. And that's only for a simple 2D polygon. So you can imagine that since GML solids and GML composite solid are formed of lower dimensionality primitives, such as polygons, then the number of ways to store a GML solid could become 1,000 maybe. And a consequence of all this is that since it's very difficult to write software, then it's a vicious circle. No one is writing software because it's too difficult and there's no example, so other people cannot look at the code of others. So we end up in a situation where we have, for example, no known JavaScript parser for CTGML files. It's 2021. I think that the web is central to a lot of what we're doing. And yet we cannot just do what we're doing here. It's with CTJSON, not with CTGML. But with CTGML, it's impossible to just take a file and write a small visualizer local where you drag a file, and you can just visualize it and query it. It's not just possible at this moment because of the complexity of CTGML files. Another example that also led me to think about all this, the usability of file, is my students. So we have the MSc Geomatics here at TU Delft. And every year I'm one of the teachers of one course that's called 3D Data Modeling for the Built Environment. And we have a few lectures about CTGML and semantic 3D city models. And when we're in the class and we explain the ideas behind CTGML, students are really receptive and really interested. So finally, what they've done in the last few months can be all applied to take cities and, for example, calculate solar potential or do visibility queries. They're really enthusiastic about it. But when we go to the lab, and then if we give them a CTGML file, then we say, can you take this file, extract something, and then perform this solar potential analysis, then it's usually their phase. And a lot of them told me quite bluntly over the years, you cannot be serious. And I was a bit ashamed, and I was like, yeah, I think it's true that it's really complex, but I was always saying, well, I was helping them, but it's really difficult. So for example, there is no Python package to be able to read fully a CityGML file. So if you just download a CityGML file somewhere, if you want to write the parser, it might take you a few, not days, a few weeks, because it just doesn't exist. And this is really a shame, because these students were really enthusiastic. They wanted to perform something, but the file, the complexity of the file that they got as input was actually the deal breaker for them to do something, or it delayed them by a few days or a few weeks to do something if they want to support all CityGML files. One other problem I see is that a lot of us here at that conference, and I spoke to a lot of people over the years, is that we promote semantic formats. So we say you should use indoor.gml, you should use CityGML, but when we go back to our desk and then we're working, and then if we're processing data, if we're reconstructing something, if we want to visualize it, we're actually not using what we prone. We're actually using OBJ and STL, for example. And we do that because these are super simple. They've been around for decades. Many communities use them. There's several software that support them. They always work. There's never problems. They work on the web. So we use them. So I just think that it's a bit hypocritical to say, use this complex format. Everyone should use them. But then in practice, a lot of us, and myself included, I'm still using OBJ as my format if I want to test something, because it just works. So what can we do about it? I think you saw me speaking a lot about the complexity. So I think that the main thing that we can do is remove complexity from the data sets that we're creating, or try to have as little complexity as possible. And this is very much in line with the rule of least powers. That it's a document that was written by the W3C 15 years ago, and one of the editors was Tim Berners-Lee. And basically it says that for information to be used and exchanged on the web, the least powerful language should be used. And by language, I don't mean C++ or Python. They mean the language, also XML or JSON, or any format to store information is a language. And basically, there's one principle that says that powerful languages inhibit information reuse. And they even say that good practice is to use the least powerful language for expressing information constrained and programmed on the World Wide Web. Since everything we're doing now is on the web, but even if it's not on the web, I think that this rule of least power should be applied, and we should aim at producing something. If we produce information, it should be as simple as possible. So concretely, what it means that I think that instead of saying we have CityGML, we should make one usable profile. So the community should say, what are the most used features of CityGML? Maybe it's 35–40% of them. And then in the same way of simple feature, make a very simple profile to say, this is the CityGML simple features. And that's what we support. And that would be way easier for the community to write parser in City, in JavaScript, make software implementation, and so on. Maintaining the whole thing, because of GML as well, is really complex. I say GML, but actually I wouldn't use any of the GML encoding. Developers don't really want that. But if it's really wanted, then also the GML should be restricted to only one way to store polygon, for example. And I think that what we should do is we should eat our own dog food. I'm pretty sure many people don't really do that. That's a principle from software development, that that's the practice of using your own product or your own output yourself. So dog fooding would mean in that case that we have our colleagues generate some files, and we use the output of these files as input for other processes in the same research group or in the same company, so that we can really test if it's easy or not to do that. And I think we should really do that. Now, the last 10 minutes or so, I'm going to speak about two projects in my research group, the 3D Geoinformation group at TU Delft, where we basically applied those principles. We started a few years ago, as I said, teaching to students that looked at me, but it's too complex, really made me think about how can I do it better. So 3 years ago, I started with some colleagues and also with the help of students in the lab, testing ideas to develop CityJSON. So CityJSON is basically a JSON encoding of the CityGML data model, but instead of using XML, GML, we use JSON. It's a human readable file. Computers will prefer this over XML, and it's also six times compacter than CTGML. So we started 3 years ago slowly. We tested it in all the courses with all the students. We asked them feedback, and we noticed right away that they were way more receptive and way more happy. They wanted because they could carry on their project, what they wanted to do, and the simple parsing of the file or modification of a file wasn't a main issue. So we've gone step by step, and since last summer, it's now an OGC community standard. All the modules of CTGML2 have been mapped. And we offer, well, it's a subset of maybe 97% of the features of CTGML that are used. Some features that we've never seen used in practice have been skipped. And some people joined us, so we now have software for the full conversion between CTGML and CTJSON. And that was really important for me. So this slide is the Python code that's needed to parse a file, a CTJSON file. And that's the only thing we need to give to students, or students learn Python. So basically they can just use the standard library JSON of Python, just open their file and start to extract information from them. They can modify that file and write it back as easily. Something that was really not possible with CTGML. And I think that these are students, but a lot of people will be like students. So scientists in other fields or like students, they're not interested in all the details of modeling and UML and ADE and so on. They just want to take a file, open it, extract something, modify it, rewrite it, and continue. And because of this simplicity and because we use JSON, which is a better language for the web, we could develop this JavaScript parser. So now this the official viewer of CTJSON, which is it's called ninja.ctjson.org, was actually started by some of our students for small projects, summer project. They wanted to learn JavaScript, so they started it. So a few students did that, and then Stelios Vitalis, PhD student in my group, improved greatly the whole visualizer and the whole viewer, and now it's online for everyone to use. And it works for all the files, not only a subset. So that's something that I'm pretty proud of, that students could do that. One thing that we're working on that I think is also very important for the future is that we want CTJSON to be ready for machine learning. And that means that we offer tutorials. How can you use CTJSON? And we can directly extract features with some CJIO, one package that we developed. And we can output data frames that can be read by pandas, and also you can do machine learning with scikit-learn. I mean, I know that it would be possible with other formats, but the output to data frame is pretty neat, I think. So it's in development. If you want to use it and give us feedback, we would greatly appreciate. And then I want to finish with the second project, which is called the 3D bar. Or the 3D bag. So that was a project that was started 2 years ago in our research group, and I wasn't part of it. This is done mostly by 4 of my colleagues. And the aim was to reconstruct in 3D every building in the Netherlands, so 10 million of them. And the idea was to take the data set of all the footprints in the country, which is called the bar. We also have which is open, and we also have a point cloud, which is open. We have 700 billion points. Was to combine these two to recreate buildings in LOD 2.2. So this is the building in which we're working at TU Delft. But basically the project meant that we do this reconstruction, footprint, point clouds 10 million times, and we do that 100% automatically. The code was written by my colleague, Ravi Peters, and it's 100% automatic, and I think it's really nice code. These are one of the best, or these are the best LOD 2.2 reconstruction that I've seen. And we wanted to be useful for users, and so we decided to not only do LOD 2.2, but we also reconstructed LOD 1.3 and LOD 1.2. And so in the file that we're giving to users, you can, for every building, get these, you get these 3 LODs at the same time, and then the users can decide which LOD is needed for their application. In the Netherlands, I think one mistake that the government made in the last few years was that they have tiles of 5.6 kilometers where they offer 2D geoinformation. All the downloads historically have been on these tiles of 5 by 6 kilometers. And when they moved to 3D, they decided to keep the same tiles because it was just simpler. But in practice, that meant that the 3D information that you had on this tile was way more than on the 2D data set. So for example, one project for the 3D model of the whole country, the files that people could download were about 2.5, 3 or 3.5 gigabytes. So the smallest file that you could get was 3 gigabytes, which meant that it was really difficult if you had a standard laptop to even be able to open them and manipulate them. And that created a lot of frustrations. So here in that project, my colleagues, they did something pretty smart. They decided to have really small files. So instead of tiling something that is constant size, they basically use a quad tree and they said we're going to have maximum 3.5 thousand buildings per tiles. So every tile is basically something like 10, 15 megabytes, which is really small and everyone can download. The download is really simple and fast. Everything is computed before, so that you just click, you download, and you can just drag it to Ninja and visualize it, which I think is a big plus. And that's something that I found very interesting. So if you remember the Swiss Topo download, the semantic 3D city models were really low. But here, these are stats about the last 2 weeks. We had 32,000 downloads, which I think is already pretty nice for an academic project. But the most downloaded format is CityJSON, 56%, and it beats easily OBJ. And if you remember, in Swiss Topo, OBJ was more downloaded than CityGML. Both were still way less downloaded than DXF. But here, maybe we should offer DXF so that we could see if we can reproduce the same result as Swiss Topo. We don't, but I'm still pretty happy that semantic models are beating OBJ, because it means that because with OBJ you only download the geometry, it's way simpler, but with CityJSON you can download everything, semantic attributes, all the LODs, and so on. What I find interesting is that we also offer the whole Postgres dump for all the buildings together, and this is more complex to use, obviously, but this is less than 1%. Also means that people really like the usability of just clicking, opening the file, looking, extracting something. One thing that we did also is that we were very careful about the geometric validity. So we made sure that the buildings that we produce were watertight, they didn't have intersection, and so on. We did that because the end users in a lot of communities, for example, in energy or in CFD, they really care about this, because if there's self-intersection or cracks or holes in your buildings, then they cannot really be used to compute the volume or to mesh them and then to do your analysis. So we were very careful about geometric validity, and in the last release, which was last week, we now have 98% of valid solids, which I think is a really nice milestone. And now I want to speak about a bit as soon as we put all the data sets on the web, something really nice happened is that people that are not really in our field decided to take the data and do something with them, which is something that really shows that the data are useful and that people are interested by this kind of data. So, for example, at the municipality of Amsterdam, they had a 3D viewer, I didn't even know, but basically they replaced all their buildings by our buildings, LOD 2.2, and they did that very quickly. They just took the data, converted them directly to their Unity environment, and then produced that nice, not produced that nice, but put them in their Unity environment, and then you can do shadow analysis, and I think that their visualization are actually nicer than the one that we have in our own viewer, because of the Unity. But it was really nice to see that without any help, they just took the data, put them there, and so they took the data and ran, basically. And also we had people in other fields that use the data, so people working with historical cadastre, shadow analysis. People took our data, wrote on LinkedIn a post to say, hey, I've used it. Some people also wrote manual tutorials for others. And the last thing that I was pretty happy to see, we have in the Netherlands a website, Tweakers, which is basically the Reddit hackers news, the Reddit hackers news in the Netherlands. That's in Dutch, but there was an article that was written about how a very geeky article by geeks for geeks that was written about how the 3D bar was created and all the technical details. And under it, there's a forum so people can discuss. But it was nice to see that people that have nothing to do with geo just got enthusiastic, took the data. Some were asking, how can I put this data into my flight simulator? How can I 3D print my house, and so on. So it was nice to see that because project was basically aimed at them, it was nice to see that they basically took the data and did something with them. All right, that was me. Thank you for listening. If you have comments or if you want to use these projects, CityJSON or the 3D bar, you can just go to the addresses there. And if you use them, then please let us know. And if you want to help us bring these tools further, then you're very much welcome to join us on our GitHub web pages and help us. All right, thank you very much.